Okay, let's start with example 1. Example 1 says, in the bag there are 2 blue chips. So here's what I normally do when I read these types of questions. Here's how I use cups. I just underline basically the categories that there are and write above each one how many there are. So 2 blue chips, 1 red chip, okay, 5 orange chips, and there are 3 purple chips. Okay. Again, this helps me just now. I can just look at 4 things and see right away what all is there. Now, one of the things that we always need to do with probability is figure out what the total is. So I always right away, okay, without even reading much more of the problem, I figure out what the total is. So let's see, 2 and 1 is 3, 5 is 8, and then another 3 is 11. So the total number of chips in this bag is 11. Now, the first question asks us, what is the probability of blue? Meaning, what is the probability that we reach into the bag and select a blue chip? Okay. Now, remember, the formula for probability is basically the way we can think about it, which we did on the previous page, was desired, okay, over number. Or you could say over, in this case, let's just say over total number. Okay, total number of possible outcomes, okay, is what that total number stands for. So in this case, we're asking for the probability of blue. So our desired is blue. Well, how many blue chips are there? Well, we underline that. It's really easy to see. Okay, 2. And then what's the total number of possible chips that we could draw? Well, there are 11 total chips in here. Okay, so the probability of selecting a blue is 2 out of 11. Okay, and you should always make sure that the fraction is reduced, and in this case, the fraction is reduced all the way. Okay, now you could write this as a percentage, as a decimal, but in this case, the fraction is the best one. Because if you do it as, say, like a decimal or a percentage, you're going to have to round. So if you do on your calculator, if you do 2 divided by 11, you get 0.18 repeating. So you could show it as, 0.18 repeating as another answer. But the fraction in this case is the best way to show it. Okay. All right. Vocab, simple event. Okay. This is actually a really simple definition. A simple event is only, one event. Okay, only one event. Okay. All right, let's do one more real quick. It says the probability of red. Well, that tells us red is our desired. So our desired is, how many red chips are there? 1. And then how many total chips are there that you could actually pick if you reached in? There are still 11. Okay, so our answer to this one is 1 out of 11. Okay, why don't you guys quickly do C and D? So go ahead and hit pause, do C and D. Okay, for C, you should have gotten 5 out of 11 because there are 5 orange. For D, the probability of purple, well, there are 3 purple out of 11 total, so that would be your answer to that one. Okay. All right, E, probability of not picking a purple. Okay. Well, look back at your notes quickly and look at the probability of not picking something. Again, take 10 seconds, look back at the previous page on your notes. Okay. So the probability of not picking purple, and make sure you use cups and really circle that not, is simply, remember all probability, the max is 100 or 100% or 1. So the probability of not picking purple is simply 1 minus the probability of actually picking purple. Essentially what this formula does is it takes out the probability of picking the purple, and then whatever is left after we've taken that probability of purple out, that's the probability of not picking purple. So in this case, we have 1 minus, well, the probability of picking purple is 3 out of 11, And if so, go ahead and do this on your calculator. If you have a big graphing calculator, you need to use parentheses around your fractions. And then it'll probably give you a decimal. You need to hit math and convert it back to a fraction. If you have a blue calculator, it's a little bit easier. Okay. So the answer that we got for this one is 8 out of 11. Okay. Again, all we had to do is subtract out the probability of actually picking a purple, and that gives us a probability that we don't pick the purple. Okay. Example A. Let's see. I want you guys to do right now. Go ahead and do example A, C, and B. Okay. Hit pause. Do those now. Okay. For A, we should have gotten 1 out of 7. Okay. Actually, I don't like when students write fractions that way. Okay. Mine takes up a little bit more room, but always write your fractions like this. Don't do the sideways part. C, we should have gotten 1 minus the probability of actually picking a Snickers, and if you did not write this down, you need to write this down. So again, 1 minus probability of actually picking a Snickers, so it'd be 1 minus 1 out of 7, and that gives us the answer to this, which is 6 out of 7. Okay, and then the last one, what is the probability that I will pick a Kit Kat? Well, there are 2 Kit Kats in the bag out of the total of 7. Okay, let's go back and look at B, because this is a new type of problem. Okay, and let's put a star on this, because this is a little bit trickier. Okay, how many times should I pick the Snickers out of 14 tries? So if you have the bag of these candies up above here, and you reach into it 14 times, and you put the candy bar back after each time, that's called with replacement. Okay, but if you reach into it 14 times, okay, always putting that candy bar back, how many times would you expect to grab a Snickers out of the bag? Okay, well, we know the probability of picking a Snickers is 1 out of 7, right? So that's essentially saying if you reach into this bag 7 times, okay, and again, always put the candy back, if you reach in 7 times, how many times would you expect to grab a Snickers? The answer is 1 out of 7, okay? Well, now what would happen if you grab 14 tries, okay? You may be thinking, well, 7 or 14 is just twice as many as 7, so I can maybe double the 1 or times it by 2, and that's actually correct, you can. But on these types of problems, okay, anytime you see like, how many times would I pick a Snickers, okay, what we're going to do is we're going to set up a proportion. Okay, we're going to set up a proportion for these. So you just start with your regular probability, 1 out of 7 is Snickers. Okay, and now you're asking, well, what if I drew 14 times? How many Snickers would I get? Okay, and if you solve this proportion using cross products, so 1 times 14 is 14, divided by 7 equals 2. So S is equal to 2. So if you grabbed into this bag 14 times, how many Snickers would you expect to grab? You would expect to grab 2 Snickers. Okay, now we're on the next page. I actually want to start down here with the vocab of what a compound event is. Okay, a compound event is simply 2 or more simple events. 2 or more simple events. Okay. So let's actually look at an example of that real quick. If we look at this number 3, part A. So we have a bag of chips, different colors, and it says, what's the probability that we pick an orange and then we pick a purple? So how many times are you actually reaching into this bag and drawing a chip? Well, you're actually reaching into it 2 times now. Okay, that's a compound event where you have 2 or more different events or trials. Okay, so now let's go back up to this right up here. So you notice in this one it said and then in particular. Okay, and actually let's write and then, because oftentimes we'll see the phrase and then. Okay. Now, I want to give you a clever little kind of saying or way to remember this. Okay, and it goes like this. Okay, let's write it down and then I'll say it. And I'm going to put above here then, because a lot of times it'll say and then. Got and, oops, sorry, that's a, should be an O. Don't tell your English teachers I spelled gotta like that. Okay, so it goes like this. Actually, let's get the next one down. So then, sorry, I made another mistake. So again, get this down, and then I'm going to say it in the clever kind of way that we'll remember it. Again, don't tell your English teachers I'm writing like this. Okay, so it goes like this. Okay, and again, this is kind of just a clever way, a catchy, with kind of a rhythm way of remembering it. So it goes, got and, gotta multiply. Got or, add them up. Okay, got and, gotta multiply. Got or, add them up. So that's the way that you can remember it, and I'll explain what that means in a second. The other way that I remember this is basically you have two words. You have and you have or. Okay, which word is longer? Which word has more letters? Okay, and that's and, right? So, and then you have two words over here. You got multiply and add. Which one is longer, the word multiply or the word add? And it's clearly the word multiply. So your two longest words, and multiply, go together. And then your two shorter words, or and add, go together. Okay. Again, you have to find these clever ways, whether it's saying it, whether it's looking at the words themselves. You have to find clever ways of remembering these kind of rules. Okay? So, let's go down to number 3 now. Alright, so in a bag there are 2 blue chips. Again, use cups, 2 blue chips. So blue, I should have just underlined blue, there are 2. 1 red, so red, there's 1. And then orange, there's 5. And purple, there's 3. So this is very similar to the last one. Now, here's the key. Okay, without replacing. Okay, that is the most important part of this. Without replacing the chip. Okay, what is the probability? So we're figuring out the probability. Okay, now let's look at this one. So the probability of picking an orange and then a purple. Now we just learned the phrase and then tells us what do we need to do with the probabilities once we find them. Do we add them or do we multiply them? And if you look up above and remember that catchy saying, and then means that we need to multiply. Okay, so underline that and then and write the multiplication symbol above. Alright, so let's just focus on the orange, which is the first grab, right? What is the probability that on the first grab we pick an orange? Well, there are 5 out of 11 that are orange. Okay, that should be pretty simple. Okay, now the next one, purple. Okay, once you reach into the bag and grab one, are you replacing that chip? And it tells us without. That means no replacement. So now, how many total chips do you actually have in this bag on your second, okay, when the second time you reach in and grab? Do you still have the 11? And the answer is no. We have 1 less because we already grabbed one. Now we only have 10. Okay, so the total possible now, there aren't 11 because we already grabbed 1. Now there's only 10. Okay, now with the numerator here, how many purple are in the bag? And there are 3 purples in the bag. Okay, now you may be thinking, well, what if you grabbed a purple on the first one? This is assuming right here, this 5 out of 11 is assuming that you're actually grabbing that orange chip first. Okay, And then, so you would still have the 3 purples still in the bag. You would just have 1 less. So let's actually put a note here. Okay, that with this 10, where we got this 10, is that we have 1 fewer chip in bag for second pick. Okay, 1 fewer chip in the bag for the second pick. Alright, now, and we already said you got and then, so we have to multiply these. So what we're going to do is we're going to multiply these 2 probabilities. So on your calculator, go ahead and multiply these, and then always make sure that your fraction is reduced all the way. Okay. So you may have gotten 15 out of 110. If you got that, it absolutely needs to be reduced because this ends in 5, this ends in 0. So we know 5 can go into both. The answer on this is 3 out of 22. Okay. So again, to recap, what's the probability that we pick an orange on the first draw and then a purple on the next? You multiply the 2 probabilities. Probability of an orange, 5 out of 11. Probability of a purple, 3 out of 10, because on the second one we have 1 less bag in the chip because we did not replace it. Okay? If you have a question on that, make sure you put a question mark or rewind it and kind of re-listen to it and rewatch. Okay. Next, vocab, dependent events. Let's actually write events here. Dependent events. Okay, is simply this. Okay, when one event occurs, it does. Okay, it does, and underline that, affect the probability, and write out the word probability. You guys should have more room than me. The probability of the next event. Okay, get that down. Okay, so if we look back up to this example that we just did, okay, the first event, once we drew the 1 chip, did it affect the probability of the second draw? And the answer is clearly yes, because it totally changed our denominator. And again, you guys don't have to get this down, I'm just going to show you. It totally changed. You don't need to make that mark. Actually, let's draw an arrow from this over to this 10 because it shows that it did affect the probability of the next event because it changed the denominator. That's going to obviously change the probability. Okay? So when one event affects another event, we say that the 2 events are dependent on each other. Okay? Alright. Let's just do the last one really quickly and then I'll have you guys do the other ones on your own. So this last one, D here. What's the probability of an orange or a purple? Okay. Now, how many times are we reaching into the bag in this? Okay, an orange or a purple. Okay, and this one, we're just reaching into the bag 1 time, and we're asking, what's the probability that we get an orange or we get a purple on that 1 draw? Okay. Now, the word or, again, really important. The word or tells us we have to do what operation? Write it above it. Okay, you hopefully should have written down the plus symbol. Remember, got and, got to multiply. Got or, add them up. So, what's the probability of picking an orange? Well, the probability of picking an orange, let's see, how many orange ones did we have? We had 5 orange. 5 orange out of 11. Plus, now, on this one, remember, we're only drawing once. Okay? So we still have the 11 bags, or the 11 chips in the bag. We're not drawing twice. Okay, so we have 5 out of 11 that are orange. And then how many are purple? Well, we have 3 out of 11 that are purple. Okay, they already have a common denominator, so you can just add them up. So this would give you 8 out of 11. Okay, So what's the probability of picking an orange or a purple? Again, this is only one draw from the bag, and the answer is 8 out of 11. Okay, go ahead and make sure you finish problems B and C, showing all of your work. When you're done with that, you can unpause it and see if you got the correct answer. Okay, so you should have gotten these answers. 3 out of 110. Now, I'm going to actually change. We should, and I should have been doing this before, we should always write all the different answer formats, fractions, decimals, and percentages, because, again, on the test, we don't know which way it's going to have. Okay, so let's convert 3 out of 110 to a decimal and a percentage. So as a decimal, if you do 3 divided by 110, you're going to get, and again, you guys should be writing this in with me, 0.0, and then only the 27 is repeating. So the line just goes above the 27. Okay, so as a percent, if you multiply that by 100, you get 2.7%. Or if we round to the nearest percent, it would be 3%. Okay, again, make sure you get all these answer formats down. Okay, for the next one, we got 1 out of 11. Okay, and if you do that as a decimal, you're going to get 0.09 repeating. And if you multiply that by 100 and then round to the nearest percentage, you would get 9%. Okay, again, make sure you get all of those answer choices down. The last one, let's see, 8 divided by 8 over 11 would be, what's 0.72 repeating. So that would be, multiplied by 100, would be 72%. Again, get all of these answer choices down. And you should have more room. Notice right here I covered up my repeating bar. Don't do that on yours. You should have a lot more room than I do. Okay? So again, from now on for all of these, write down all of the answer formats, and let's just round to the nearest percentage. Round to the nearest whole percentage. Okay, why don't you guys right now go ahead and do on your own E, D, and F. Okay, so hit pause, do those 3. When you're done, you can unpause it and check your answers with mine. And again, you guys, it is your responsibility to come to class making sure that you understand these. So you need to try these on your own, double check your answers, and then check with the answers that I have. Okay, check your answers with mine. Again, if you got one of these wrong, I highly suggest you mark it wrong. That way when you study your notes, you know exactly which ones to prioritize before the test. Okay, again, make sure you check each format, fraction, decimal, and percent. Okay, if you're not done checking, make sure you hit pause, or if you got one wrong, make sure you take a look at my work. Alright, let's do the next one. Now, this one is kind of tricky, okay, and the reason why is because you may be thinking, oh, it's got and, so I got to multiply. Okay, that might be what you're currently thinking. Now, think about this. It says, what is the probability that you pick a purple and orange? How many picks are you going to do, or how many draws from the bag are you actually doing in this one? Okay, and the answer is you're only drawing once. It doesn't say and then, or just then, meaning you would have 2 picks, right? It's saying you reach in the bag and you pick a purple and an orange. Okay, if you think about that, if you can only pick one, there's no way that you can reach into the bag and pick both, a purple and an orange at the same time with just one draw. Okay? So, here's what we say about these 2 events. We say that these 2 events are mutually exclusive, which is the next vocab word. Okay? Here's what mutually exclusive means. It means that 2 or more events. Let me rewrite that. 2 or more events cannot occur at the same time. Okay, or together, you could say. The 2 events cannot occur at the same time. So, if you think about another example of this, think about flipping a coin. Okay? If you flip a coin once, Okay, can you get both a heads and a tails on that one coin flip? And the answer is no, it's impossible. Okay, so let's get kind of that example down because that'll help us remember this vocab word. Okay, that it's impossible to flip coin once and get heads and tails. It's impossible. So we say that those two events are mutually exclusive events. Okay, mutually exclusive events. All right. Why don't you guys go ahead and do these next two problems, or these next three problems. Okay, so again, do these next three, make sure you read them carefully, use cups, and then, so hit pause, and when you're done, check your answers with mine. Okay, here are my answers. Double check all of your answers with mine. If you got one wrong, make sure you mark it wrong, again, that way you know which ones to go back and study. And if you get it wrong, try to go back and correct it. And if you still have questions about it, after you've tried correcting, that's where you put a big question mark and you can ask that question in class. Okay? That's going to be it for this video.